Okay, now we have to determine what we would have expected to happen, all right? And in order to do that, what we want to do is we want to calculate the gram molecular weight of sodium bicarbonate, okay, or baking soda. And the chemical formula is Na plus, which is sodium, and C for carbon, O, 3. Now remember that's a subscript. I'm not playing around with that right now. All right, so what do we need to calculate? Well, we know sodium, and we need to know its atomic weight. And actually, that should have been cut. That should have been up here at the top. And actually, I want to get rid of the little space in between, so I'm going to go delete. All right, now sodium's atomic weight is 23. All right, and carbon, its atomic weight is 12. And oxygen, its atomic weight is 16, and I left out something because I wasn't paying attention. There should be a hydrogen here. And hydrogen's atomic weight, sodium, carbon, that should be oxygen. Let's try that again. There we go. And hydrogen, which has an atomic weight of 1. There we go. All right, so let's figure out what the atomic gram molecular weight of sodium baking soda is. So there's 1 sodium, there's 1 carbon, 3 oxygens, and 1 hydrogen. All right, and when you add all these guys together, when you do the formula, this is going to equal 1 sodium times 1 atom of sodium. Oops, I really can't type either. All right, 1 sodium times 1 atom. And I'm just going to drag that formula down, get the little black cross, and that gives me the number. All right, and all I have to do is click below it and hit sigma, and that sums everything up. And that gives me 52. All right. Okay, now it looks like I made a mistake here because this is supposed to be... Okay, you know what? Now, see, this is why you check what you're doing. If you take a look at this, it says 16 times 3 is 16. And I'll tell you what I did wrong, which I can't believe I did anything that dumb. When I typed in the formula, instead of grabbing the cell, I typed in the number 1. Okay, I should have clicked on this cell. Okay, I shouldn't have multiplied by 1. I should have multiplied by C2 and hit enter. Now you notice 23. Now all of these stay the same, except for the one where I was supposed to multiply by 3. Boom, there you get 48. Now that looks a little bit better. All right, now remember how I told you that Excel was for really, really lazy people? Let me show you a trick. Now what we want to do is we want to calculate, okay, what's the atomic weight of carbon dioxide? CO2. Well, I could just redo all these formulas again, or if I'm really being lazy, I can click here, copy over here, and then just paste this right below the carbon dioxide. All right, now you notice it's like, okay, sodium. Well, carbon dioxide doesn't have any sodium, so I can just click on the row here and delete that row. Watch what happens over here. Watch what happens to this guy over here when I do that. So let's delete that. See, it dropped. And we're going to get rid of the hydrogen. We're going to delete that. Oops, dropped again. And we went from 2 oxygens to 3 oxygens to 2 oxygen, putting that in, boom. And that gives us the actual weight of carbon dioxide. So, if you actually subtract, if you wind up, let's figure out what percentage of this formula, all right, is... Let's figure out what percentage of the formula is the carbon dioxide. All right, let's figure that out. All right, so what I'm going to do, percent. What's this percent difference between the two? All right, and so what we're going to do is we're going to say is, this is a formula, equals 44 is what percentage slash of 84. Boom, and it should be 52%. And I'm just going to convert that into a percent by clicking on the percent key up here. All right, so that's the amount of weight we should have lost. Okay, that's what the negative number should be. All right, so we're going to go and we're going to see if we're going to use that to see how far off we actually came. All right, in other words, did we actually, how far are our numbers off of that?